Layer 2 of the OSI model is the data link layer. Its primary purpose is to prepare data for transmission across the given network media. Data at this level is given a more robust structure, a destination, a source, and then broken into bits to be sent out on the network. I will be describing the Ethernet 2 frame format because it is the most commonly used Ethernet frame type on the Internet today. Before a Layer 3 packet can be put out into the media, the NIC must encapsulate the Layer 3 packet so that it can be transmitted as the frame of Layer 2. 5 extra things need to be added to a packet to turn it into the Ethernet frame that has the capability to be instantaneously responded to as it travels across the network, and the durability needed to ensure data reaches the other NIC safely. In order, these things are the preamble, the destination MAC address, the source MAC address, the ether type, and the FCS at the end after the Layer 3 packet. The introduction to each frame is the preamble. The preamble consists of 8 bytes that mark the beginning of a packet and contains an alternating pattern of 1s and 0s. The final byte of the preamble ends in 2 1s and signals the start of the actual data. The starting point is called the SFD, or Start of Frame Delimiter. The first and second item added to a frame are the destination and source MAC addresses. This is used by all Layer 2 capable devices to instantly identify where the frame in question will be going on the network and from which device it came from. These addresses are both 6 bytes long and are unique to the NIC that it was transmitted from or going to. The ether type is a 2-byte field after the destination and source MAC addresses. Its purpose is to label the type of the packet passing over the network. At a glance, it can be determined which of the tumult of types the packet belongs to, including IP version 4, IP version 6, PPPoE, ARP, Wake on LAN, or even if it's just a jumbo frame. The last field is the FCS, or Frame Check Sequence. This 4-byte field at the very end of each Ethernet frame is the key item that makes an Ethernet frame resistant to error. After all the other items of a frame are assembled, it is analyzed using an algorithm to create a checksum. This checksum is like a packaging slip for the NIC at the other end and contains an overview of the contents of the frame. If the FCS and the rest of the frame do not match, the entire frame is discarded. After the frame is complete, it is divided into bits and transmitted 1 bit at a time across the transmission media to be received in the same order by the NIC at the other end.